Exercise 2.5, question number 5. Prove that 3 power 2n minus 1 is divisible by 8 for all n belonging to capital N. Now, till the previous problem, we were doing LHS equal to RHS pattern. Hereafter, we are going to do problems based on divisibility. First of all, what do you mean by the idea divisible? The word divisible says, suppose I take 16. It can be written as 2 times 8, 24, 3 times 8, 48, 6 times 8. So all these I will say divisible by 8. So what do you understand? Whenever I say divisible by 8, it is a multiple of 8, or in general I can say 8c, 8m. So multiple 8m I can say, or 8c or 8n, like that way. Divisible by 8 tells me it is equal to 8m for some m. Okay, now coming back to the question, P of 1 is true. I want to show. Wherever n is coming, put 1. 3 power 2 into 1 minus 1. 3 square is 9 minus 1. I get 8. Is 8 divisible by 8? 8 can be written as 1 times 8. So naturally, it is divisible by 8. Therefore, P of 1 is true. Third step, assume P of k is true. Just copy the question. Wherever n is coming, put k. So 3 power 2k minus 1 is divisible by 8. A little before we said divisible tells me it is a multiple of 8. So how will I write it? 3 power 2k minus 1 is 8m, or 3 power 2k can be written as 8m plus 1. Call this as number 2. We will call the given question as number 1. The next step, to prove that P of k plus 1 is true. So again copy the same thing, 3 power 2. In the place of k, I will put k plus 1 minus 1. How will I split it? 3 power 2 into k, 2k, plus 2 into 1, 2, minus 1. The next step, 3 power 2k into 3 power 2. In power you have plus symbol, base I will multiply. 3 power 2k, 3 power 2 I will multiply minus 1. What is 3 power 2k from this step? It is 8m plus 1. So 8m plus 1 into 3 square is 9 minus 1. Now multiply like this. 8m into 9 is 8m into 9 plus 1 into 9 is 9 minus 1. What is 9 minus 1? 9 minus 1, I can write 8. Now, which is common in these two? In both the steps, I have 8 common. Take 8 out, I am left with 9m plus 1. So, as I take 8 out, I am getting 9m plus 1. So, I will say 8 into something. So, it is divisible by 8. So, I am able to show P of k plus 1 is also true. So, we will take and write implies P of k plus 1 is true. Therefore, P of n is true for all n belonging to capital N. We'll see the steps once again. Whenever it is given divisible, first step, P of n, no problem, copy as it is. P of 1, wherever n is coming, put 1. Check whether it is divisible by 8. Assume P of k is true. Copy the given question. Wherever n comes, put k. The next step, to prove that P of k plus 1 is true, the same thing we copy. In the place of k, we put k plus 1. Now multiply 2k plus 2. whenever the power we have plus symbol, split it. 3 power 2k into 3 power 2, which reduces to 3 power 2k is 8m plus 1. As I multiply, I am able to take 8 out. So, when I am able to take 8 out, I will say it is divisible by 8, and so P of k plus 1 is true. P of n is true for all natural numbers. Exercise 2.5, question number 6. A power n minus b power n is divisible by a minus b for all n belonging to capital N. We will assume the given question in P of n. The first step to prove that P of 1 is true. Wherever n is coming, put 1. So what will I get? P of 1 colon a power 1 minus b power 1. Of course, I get a minus b, and I know a minus b is divisible by a minus b. Therefore, P of 1 is true. Assume P of k is true. The same thing we have copied. In the place of n, k will come. To prove that P of k plus 1 is true, we have to use some ideas from here. So, a power k minus b power k. Divisible by a minus b tells me m into a minus b. The next step, keep a power k in the left, bring b power k to the other side, b power k plus m into a minus b. Call this as 2, call the given question as 1. We will use this in the next step. What is my next step? To prove that P of k plus 1 is true. Wherever k is coming, put k plus 1. How to split it? A power k, a power 1 minus b power k, b power 1. So, whenever you have two terms in the power, split it. A power k, a power 1, b power k, b power 1. Now, in the place of a power k, I can substitute b power k plus m into a minus b into a minus b power k into b. Now we shall multiply. A power k, we have written b power k m into a minus b into a minus b power k into b. Now multiply this a like this way. What do you get? B power k into a plus m a into a minus b minus b power k into b. Now in these two terms, combine these two. Which is common? As I combine, b power k is common. Let me take b power k out. If I take b power k out from here, here a is left, here b is left, in between minus symbol. So I will write b power k into a minus b plus m a into a minus b. In both the cases, which is common? A minus b. What is left out? B power k plus m a. So, I get a minus b into something in the bracket. Whenever I get a minus b into something, I will say this is divisible by a minus b, because I have a minus b into something, some number. So, it is divisible by a minus b. That shows P of k plus 1 is true, and so P of n is true for all natural numbers. Exercise 2.5, question number 7. Show that 5 power 2n minus 1 is divisible by 24. We have already done many problems. We can just outline. 5 power 2n minus 1 divisible by 24 is P of n. To prove that P of 1 is true, wherever n comes, put 1. 5 square minus 1, that is 25 minus 1, 24 is divisible by 24. So P of 1 is true. Wherever n comes, put k. When I say divisible by 24, write 24m. Bring minus 1 to the other side as plus 1. Now I want to show P of k plus 1 is true. Wherever k is coming, put k plus 1. How do I simplify the answer? 5 power 2 into k 2k, 2 into 1 2 minus 1. Or I can further write this as 5 power 2k into 5 power 2 minus 1. Or it is 5 power 2k, I can substitute from here. 5 square into 5 power 2k is 24m plus 1 minus 1. Multiply like this. 5 square is 25 into 24m plus 25 into 1 minus 1. Combine these two. 25 into 24m plus 24. In these two terms, 24 is common. So I can write 25m plus 1. 24 into some number we have derived. Our idea is divisible by 24. That means I must have 24 into some number. So we will say this is divisible by 24. Therefore, P of k plus 1 is true. Therefore, P of n is true for all n belonging to capital N, and that is the answer. Question number 8. Show that n into n plus 1 into n plus 2 is divisible by 6. First few steps already you know, so you can write on your own. When we come up to P of k plus 1, k plus 2 is divisible by 6 tells me it is 6m. When we want k plus 1, k becomes k plus 1, k plus 1 plus 1, k plus 1 plus 2. Or we write k plus 1, k plus 2, k plus 3. Now multiply. These two are already here. K plus 1, k plus 2 are already here. So these two I can have together. K into this, 3 into this. That is what we are going to write. So how I am going to split this? K into k plus 1 into k plus 2 plus 3 into k plus 1 into k plus 2. So k plus 1, k plus 2 we are going to write in both the terms. One term I put k, another term I put 3. K plus 1, k plus 2 is here, which I can write 6m. So this let me call 1. So from 1 we are writing. The next term 3 k plus 1 into k plus 2. My question is divisible by 6. How am I going to explain? 6m divisible by 6. Here also divisible by 6 should come. But 6 I can write 2 into 3. So divisible by 6 tells me it should be divisible by 3 and divisible by 2. 3 is already here. Out of the two factors, if this is odd, this will be even. Odd. If this is even, this will be odd because they are next numbers. 6 and 7, 7 and 8, 8 and 9, 9 and 10. So consecutive numbers, one number is odd, another number is even. So I will say out of the two, any one number is definitely even number, and so every even number is divisible by 2. So 3 into k plus 1 into k plus 2 is also divisible by 6. So we say this is divisible by 6. When I am able to show both the terms are divisible by 6, I am able to declare P of k plus 1 is true. Therefore, P of n is true for all n belonging to capital N. So this particular problem we need to explain little more. From 1 is actually here. The working we have done, understand. Out of the two terms, one is odd, the other one is even. So any one of this is definitely even and so divisible by 2. Already 3 is coming, so divisible by 3. 3 into 2, 6. So ultimately, it is divisible by 6. P of k plus 1 is true and we have shown the problem. Question number 9. Prove that 2 power n greater than n for all n belonging to n. Take the given question as P of n to prove that P of 1 is true. Wherever n is coming, put 1. 2 power 1 greater than 1 is true. Yes, because this is 2, 2 is greater than 1. Therefore, P of 1 is true. We will proceed on to assume P of k is true. What is P of k? 2 power k greater than k, and we have already proved for 1 k will be definitely greater than 1. Every time I have proved for 1, assume for a number which is more than 1. So mention k greater than 1. The next step, I want to show P of k plus 1 is true. What is P of k plus 1? It is 2 power k plus 1. How to write 2 power k plus 1? 2 power k plus 1 can be written as 2 power k into 2 power 1. What is 2 power k from here? 2 power k is greater than k. So I will write this is greater than. 2 power k is greater than k. So 2 power k greater than k into 2. K into 2 can be written as k plus k. 1k you keep as it is. 1k, let me use this idea. What is this idea? K greater than 1. So for 1k, let me write greater than 1. So again what symbol? 2k I write k plus k. 1k you write as it is. 1k I can use this idea greater than 1. So we started with 2 power k plus 1, ended with greater than k plus 1. So I am able to show P of k plus 1 is also true. Therefore, P of n is true for all n belonging to capital N. Exercise 2.5, question number 4. Prove that 1 plus 4 plus 7 up to 3n minus 2 equals n into 3n minus 1 by 2. Take the given statement as P of n. To prove that P of 1 is true, LHS the first term, RHS wherever n is coming put 1. 1, 3 ones are 3 minus 1 by 2. So as we simplify, we get 1. LHS equals to RHS implies P of 1 is true. Assume P of k is true. Copy the given question. Wherever n is coming, put k. The next step, to prove that P of k plus 1 is true, LHS copy the same plus write one more term, 3 in the place of k, k plus 1 minus 2. Simplifying this, 1 to 3k minus 2, use this idea. K 3k minus 1 by 2 plus multiply this 3k plus 3 minus 2, or simplifying this I can multiply 3k square minus k by 2 plus 3k, 3 minus 2 is 1. Now we'll take LCM and simplify. It is 3k square minus k, 2 into 3k 6k, 2 into 1 2 divided by 2, or I can write it as 3k square 6k minus k, 5k plus 2 divided by 2. Now we will go on to the RHS. What is RHS? Wherever k is coming, put k plus 1. 3 into k plus 1 minus 1 divided by 2. Or I get k plus 1 into, multiply like this, 3k plus 3 minus 1 by 2. Or I get k plus 1, 3k plus 2 by 2. Check whether these two are equal. Multiply here, 3k into k, 3k square. 3k into 1, 2 into k, 2k, together 5k. 3k plus 2k, 5k. 1 into 2, 2. So this and this are equal. Call this as 1, call this as 2. 1, 2 imply LHS equal to RHS, or we will say P of k plus 1 is true. Therefore, P of n is true for all n belonging to capital N.